Hi, good day everyone. I am Yongwen Jin and my metric number is 0319F1005. Today, me and my group member Iko, Fitra and Sofia is going to talk about the indicators of climate change. Before we start our presentation, let me show you a video. What is climate change? Climate change refers to the long-term shift in temperatures and weather patterns. This shift may be natural, such as through variations in the solar cycle. But since the 1800s, human activities have been the main driver of the climate change, primarily due to burning fossil fuels like coal, oil, and gas. Burning fossil fuels will generate the greenhouse gases emission that act like a blanket that wraps around the earth, trapping the sun heat and raising the temperature. One of the climate change indicators that I'm going to talk today is the concentration of greenhouse gases in the atmosphere. Before that, let me explain to you what is the greenhouse gas. A greenhouse gas, which we know as GHG, is a gas that absorbs and emits the radiant energy within the thermal infrared range, causing the greenhouse effect. The primary greenhouse gases in Earth's atmosphere are water vapor (H2O), carbon dioxide (CO2), methane (CH4), nitrous oxide (N2O), and ozone. Increasing emission of greenhouse gases due to human activities worldwide have led to a substantial increase in atmospheric concentration of long-life and other greenhouse gases. This figure shows the worldwide emission of carbon dioxide, methane, nitrous oxide, and several fluorinated gases such as HFC, hydrofluorocarbons, PFC, perfluorocarbons, and FF6, which is sulfur hexafluoride from 1990 to 2015. For consistency, the emissions are expressed in million metric tons of carbon dioxide equivalents. This total includes the emissions and sink due to the land use change and forestry. Let's look at the graph. In 2015, estimated worldwide emission from human activities totaled nearly 47 billion metric tons of greenhouse gases, expected as carbon dioxide equivalents. This represents a 43% increase from 1990. These numbers represent net emission, which include the effects of land use and forestry. Between 1990 and 2015, the global emission of all major greenhouse gases have increased. Let's refer to the graph. The net emission of carbon dioxide increased by 51%, which is particularly important because the carbon dioxide accounts for about 3/4 of total global emission. By the way, the methane emission was increased the least, 17%, while emission of nitrous oxide increased by 24%. Emission of fluorinated gases more than tripled. As the simplest way to explain about the graph and a short conclusion for my part as well, The greenhouse effect that will cause climate change is being serious. Compared with the whole graph, 1990 have the lowest concentration of greenhouse gases, but 2015 have the highest concentration of greenhouse gases in the atmosphere. The concentration of greenhouse gases is increasing year by year due to the human activities, land use, and forestry. The greenhouse effect will cause the global temperature being higher and higher. Next, I would like to pass it to my group member to talk about her point.
Hi madam, my name is Ikung Doctor of In. My metric number is 03DSB19F2056. Okay madam, I continue. My topic is heavy precipitation. My graph for heavy precipitation. Okay, the first is the most immediate impact of heavy precipitation is the prospect of flooding, and then this risk can be heightened in urban area where impervious pavement for water to quickly run off into sewer system. Okay, the next is the first month in August 2017. Hurricane Harvey affected 48 inches of rain on Boston, breaking the US record for most rainfall for a single event, and demonstrating that the bigger threat from tropical cyclone and is not away coastal flooding and wind damage. Okay, the next month is in July 2016. More than 6 inches of rain fell in True House in history in Ellicott City, Maryland. Okay, causing more than $22 millions in the damage. Okay, the next month is in September 2013. Boulder, Colorado received almost a year's worth of rainfall in 17 inches in 4 days. Okay, the resulting flooding destroyed homes, shut down thousands of oil and gas, okay, and damaged crops. Okay, continue in years 2010. Almost 20 inches of rain fell in the Nashville, Tennessee area over 3 days. Loss in Nashville alone totaled over 1,000 millions. Okay, the next is in addition of flooding, heavy precipitation also increases the risk of landslide. Okay, when above normal precipitation release the water table and saturated the ground and slope can lose their stability, causing a landslide. Okay, Washington State, which has a particularly high risk of landslide due to its terrain, is anticipating more frequent landslide as a result of climate change, indicate increase in heavy downpour. Many cities in the United States use a combined sewer system where both stormwater and wastewater are mixed, treated, and released. Having rainfall can overwhelm such system, sending excess stormwater, wastewater, and untreated sewage directly into the environment, risking public health and disrupting local fisheries. Okay, the next is how to build resilience. Okay, the first is community can reduce in impact of heavy precipitation by updating zoning regulation so that buildings in infrastructure are built on hectare ground or in area that are less prone to flooding. Okay, the second is updating building code and design guideline to risk building. Okay, the next is using flood control infrastructure as was done, for example, by the Port Authority of New York and New Jersey of Hurricane Sandy. Okay, after that, limiting the use of non-permeable surface like pavement and concrete in developed area, or replacing pavement with green infrastructure. Okay, that can reduce runoff and flood risk during storm. Okay, the next is incentivizing action to reduce flood risk, like to include in the national flood insurance program community rating system. Okay, and then pushing flood insurance to cover property losses and building disruption. And then lastly, separating stormwater system from wastewater system, using holding pond and increasing water treatment capacity to avoid sending untreated sewage into local waterway.
Hi, my name is Aminul Fitra binti Mahamud. So now I will be continuing about this topic. In this graph shows sea level change average over the entire Earth's ocean surface. This long-term data set has been calculated through 2013, while satellite data are now available through the end of 2019. Global average sea level rose throughout the 20th century, and the rate of a change has accelerated in recent years. Absolute sea level has arisen at an average rate of 0.6 inches per year from 1880 to 2013. Since 1993, however, average sea level has arisen at a rate of 0.12 to 0.14 inches, roughly twice as fast the long-term trend. Relative sea level has also not risen uniformly because the regional and the local changes in the land movement and long-term changes in a coastal calculation pattern. Temperature and sea level are linking for two main reasons. First, change in the volume of the water and ice on the land can increase or decrease the volume of water in the ocean. Second, as a water warms, it expands slightly. Changing a sea level can affect human activity in a coastal area. Higher sea level also make coastal infrastructure vulnerable to damage from storm. Scientists account for this type of a change by measuring sea level change two different ways. Relative sea level change refers to how the higher of ocean rises, the higher of ocean rises or fall relative to the land at a particular location. In contrast, absolute sea level change refers to the higher of the ocean surface above the center of the Earth. without regret to where the nearby land is rising and falling. Measure relative sea level change at a point along the coast, while a satellite instrument measured sea level change over near the entire ocean surface. That's all. So next, it will be continued with Sophia.
Assalamualaikum, my name is Nur Sofia Nadia binti Muhammad Asmawi and my matric card number 03DSP19F1010. So for the next topic, we will talk about describe global trend in a sea surface temperature. So the temperatures of the water at the ocean surface is an important physical attribute of the world ocean. So the surface temperatures of the world ocean varies mainly with latitude, with the warmest water generally near equators and the coldest water in the Arctic and Antarctic region. So as the ocean absorbs more heat, sea surface temperature increases and the ocean circulation pattern that transport warm and cold water around the globe change. So this indicator track average global sea surface temperature from 1880 through 2000. It also includes a map to show how change in sea surface temperature has varied across the world ocean since 1901. So this technique used for measuring sea surface temperatures have evolved since the 1800s. So for instance, the earliest data we collected by inserting a thermometer in a water sample collected by lowering a bucket from a ship. So the temperature measurements are collected more systematically from the ship as well as at the stationary and drifting buoys. So this map shows how average sea surface temperature around the world changed between 1901 and 2020. So it's based on a combination of direct measurement and satellite measurement. So a black plus symbol in the middle of a square on the map mean the trend shown statistically significant. So wide area did not have enough data to calculate reliable long-term trend. So this another of the graph show the average surface temperature of the world ocean have changed since 1880. So this graph used to the 1971 to 2000 average as the baseline for depicting change. So choosing a different baseline periods will not change the shape of the data over time. So the shaded band show the range of the incongruity in the data based on the number of measurements collected and the precision of the method used. So sea surface temperature increased during the 20th century and continued to rise. So from 1901 through 2002, temperature rose an average rate of 0.14 F per decade. So sea surface temperature has been consistently higher during the past 3 decades than at any other time since reliable observation began in 1880. So based on the historical record, increase in sea surface temperature have largely occurred over 2 key periods between 1910 and 1940, and from about 105 and from about 1970 to the present. So sea surface temperature appears to have cooled between 1880 and 1910. So change in sea surface temperature vary regionally. So while most parts of the world ocean have seen temperature rise, a few areas have actually experienced cooling, for example part of the North Atlantic. So for the conclusion and recommendation is, climate change is not curable nor can slow down the effect of the manifestation to the society, economy, environment, and the sustainability of the future planet. So climate change has impact to the global food supply because it can affect food prices at home. So food shortage abroad can pose humanitarian crisis and national security concerns. The pattern of weather condition will not anymore be predictable, and range of the impulsive weather condition will be stronger and heavier. So this is all for me. Thank you.